model, it'll try to do a decision boundary between the two classes. Try to open those slides. Okay, yesterday there were some good questions asked by Giri and Shashiram. So binary class classification tries to do a decision boundary between two classes like that, and there will be a decision score and there will be probability, right? Either one we can use, and I would prefer using decision score because some algorithms will not emit a probability until and unless we explicitly say. Even logistic regression will not give you probability until and unless you use the what you call it as a log loss function. Okay. So in binary class classification, we understood all the concepts of how to measure the accuracy of the model and which metrics are good and which metrics are bad in measuring the accuracy of a imbalanced data set. You remember, I hope, all these things. Okay. Any questions on any of these topics you can ask even now. Okay. On an imbalanced data set, accuracy measure is not right. Accuracy actually looks into how many predicted correctly. It will not look into how many positives correctly predicted and how many negatives correctly predicted. There are 4 combinations I showed you. So all those 4 combinations it's not going to consider. So that is the problem with the binary class, accuracy score. So that's where we went into precision and recall. Okay. When we looked into precision, it is trying to explain out of total positive predictions how many are correct. Out of total positive predictions, how many are correct? With respect to algorithm, it is talking about. It is talking about the accuracy. If you look at recall, out of existing positive records, how many are correctly predicted? So there are 2 things, right? So there will be existing records in the data set which are positive, and algorithm need to predict them correctly. That is one thing. And there are predictions made by the algorithm, and they should be correct. Both the algorithm is looking into positive case only. It is not looking into. It is not majorly considering the negative case. Why did we do that? On an imbalanced data set, it matters a lot. Okay, on an imbalanced data set, uh, correctly predicting the positive records matters a lot, because we are going to give the positive records label 1. Okay, the target variable, the positive records label 1. The negative records will give 0. The majority class will be given 0. Minority class will be given 1. Right? So those all concepts you understood. Right? Those all concepts are here in the slide, and you can actually go through them. And then we understood the logistic regression, right? The equation. Why this equation? It is actually trying to generate a number between 0 and 1. Why do you want to generate a number between 0 and 1? The target variable value is 0 or 1, right? When you are building a model, algorithm always try to generate a number which is close to the target variable. This is also kind of a regression only, right? But we took, this equation is kind of a gamble, right? We are trying to take a equation that is generating a number close to 0 or close to 1. Okay, when I say this is also kind of a regression, there will be infinitely many numbers between 0 and 1. It is trying to generate numbers, but in a closed circuit, right? In regression, it is going to generate numbers infinitely many, right? Like the range is infinite, right? So you got all those concepts, and in the multi-class classification, the algorithm will try to do multiple decision boundaries. So here, one question asked was, decision score. But will there be, a decision score on a multi-class classification? Will there be a case where all decision scores are going to be negative. That's one question. So on a binary class classification, you will have one number, one decision score for each class. It is the distance between the decision boundary and the data point. If some data point wrongly predicted, that means this data point fell on the bottom side of the line, but the decision score of that data point is going to be negative. That means algorithm is going to predict it as negative, but actually it is not negative. That's an error, right? Anyway, the precision recall, the scores will try to elevate, how many correctly, how many wrongly predicted, things, right? So decision score is algorithm's perspective. Reality, maybe it is positive. In algorithm, it may have understood it is wrong, right? I actually wrote a perfect line here, but if the line went like that, right? Then these 3 points would have been wrongly predicted, and those points decision score would have been negative. Okay. On a multi-class classification, you will have multiple decision scores. If you look at this, I have 10 classes here in this data set. I have taken this multi-class classification data set, right? All the labels I have taken, right? 0 to 9. I did not made any manipulation there, right? 0 fives and not fives like that. I did not convert any target variable and took the original data and built a model. Now I have got 10 decision scores. The question was, can we have, I think that the probability, can we have, all decision scores negative? No, I would say no, because the algorithm, one of the line will, if you look at this diagram, there are 3 decision boundaries. I actually wrote it till here only, but this line can expand like that, right? Like that. And this line can expand like that. This line can expand like that. When it expands, right, one or the other data point will fall on the positive or negative side. For any one of the decision boundary, the data point will fall on the positive or negative side. When it falls on the positive side, for that decision boundary, it's going to be positive decision score. Okay. For the other decision boundaries which are falling on the, where the data point is falling on the negative side, the decision score is going to be negative. But sometimes, right, many decision boundaries, for a data point, the decision boundary may be on the positive side. In that case, right, you will get more positive numbers, less negative numbers. But ultimately, what we are going to take, the argmax of the decision boundaries are probabilities. What is argmax? The index where the value is high. If you look at these decision boundaries, right? If you look all the numbers, right, this is the highest number in all these 10 numbers. For 10 classes, you will get 10 decision boundaries, because 10 decision boundaries and 10 decision scores. Decision score is the distance between decision boundary and the data point, right? This is the highest number. When you say argmax, right, you will get the index of this decision boundary. That is the prediction. The index of the highest um, decision score is the prediction. This point is very important in deep learning. How exactly the classification algorithm is predicting, right? By looking at the argmax of the decision boundaries or the probabilities it is predicted, right? So that is the recap in 5 minutes, maybe 8 minutes I took. Any questions so far? Did I answer your question, Harigar, Girigar, and Shashiram?
Yes, sir.
Yes, sir. I have actually, gone through the yesterday's class again.
Yeah.
Yeah, it got clarified.
Yeah, I got confused a little bit and said, here and there. Maybe, may not be kind of words I used, but it is not maybe, it is math, right? We should always say exactly right. Not like COVID. Scientists in COVID, they say maybe, may not be, right? It is not science.
There's one question.
Yeah, please.
So, so we are taking the argmax of the decision decision function,
Ah.
which has the highest value, maybe
Mm.
highest positive value.
Mm.
So what is the significance of the predict probability function in this case? Because at the
Either
same
one.
arg value, same argument, we have the highest value.
Ah.
So I mean, like, why we need to take both? I mean, what is the significance there? Taking.
Some implementations, say, by scikit-learn will have only decision function, not predict proba. Got it? It is implementational issue, not the conceptual issue or the algorithm internal. It is scikit-learn implemented with people who implemented scikit-learn module, the algorithms. Some algorithms they gave only decision function. Some algorithms they gave only predict proba. We need to understand both. Got it?
Yeah, okay. But
Implementation issue. Yeah.
yeah, but in both the cases, at the same argument, we will get the highest positive.
Yes. Yes.
Okay.
Yes. Okay. Any other questions? Okay. So today we look into error matrix on multi-class classification. It is same as the binary class classification, right? So multi-class classification is a magnification, right? A magnified version of binary class classification. If you look at our binary class classification, we took our original data and converted it into a binary class, built a model, right? In multi-class classification also it is doing the same thing. It took the original data, created a binary class for triangle and others, built a model, created a binary class data for circle and other, built a model, created another data set for triangle and others, built a model. We are converting our original data set into 3 data sets and building 3 models. When a new record comes in, we'll pass the record to all 3 models. Wherever the probability is high, we say the record belongs to that class. If this model is giving high probability, then we say the record belongs to triangle. If this model is giving high priority, high probability or high decision score, we'll say the record belongs to circle. If this model is giving high probability, we'll say the record belongs to rectangle, right? It's a magnified version of our binary class classification is the multi-class classification. So the metrics are also going to get magnified. Simple, right? Simple. In a conceptual way, it is simple. So if you look at the confusion matrix, how do you do confusion matrix? In scikit-learn metrics, there is confusion matrix, there is precision score, there is recall score, there is F1 score, there are other metrics also. Okay, MSC, RMSC, negative RMSC, those things are there. You may look into the module and you'll find many things there. Okay, confusion matrix. How do? You pass the original y and the predicted y. Okay, original y and the predicted y. It is going to calculate confusion matrix. When you pass original y, predicted y, how is it actually calculating? By looking at how many positive predicted correctly and how many negatives predicted correctly, right? How many positives predicted correctly, how many negatives correctly predicted, how many positives wrongly predicted as negative, how many negatives wrongly predicted as positive. By looking at these counts, it is calculating the precision and it's actually taking those counts and putting into the confusion matrix. Simple, right? So here, if you look at this first row, what is the, if I take the count of total sum of all these numbers, what is that? Can you tell me? Sum of all these numbers, what is that?
Total negatives.
Total negatives of which class? First row.
First, mm,
Zero
zero.
class.
Yeah.
Yeah, good. Second row?
1, 2, 3.
One, one,
One,
two, three,
two,
like
three,
that,
like
right?
this.
Yeah,
Yeah.
0, 1, 2, 3. All actual, zeros. Actual ones. How many actual ones are there? How many actual twos are there? Actual threes are there, right? Like that. Right? Row is the count of actuals. Column is the count of predicted. right? Actual zeros, 3154 were predicted as zeros, but 5 were predicted as 2. 5 zeros were predicted as 2. 5 zeros were predicted as 3. 5 zeros were predicted as 5. No, 27 were predicted as 0, 1, 2, 3, 4, 5. Right? 28 zeros are predicted as 6. Right? 2 zeros are predicted as 7. 58 zeros are predicted as 9. Generally 9 is going to be close to 0. If the tail is not given high, big tail is not given, so it looks like 0. So model is getting confused, right? When you take the pixels and pass
It is
the
it is
label,
it,
sorry,
it is actually 8.
8, sorry, yeah, 8.
5 and 8 are
Yeah,
something like that.
yeah. 0
9
and
is 0.
yeah, 8. So 5, 6 and 8 are getting confused, right? 6 also, tail is the problem. I don't know 5, why it is getting confused, but people write differently, right? Many people write differently. Maybe in this data set there is lots of noise in the data. So that's like, by looking at the confusion matrix you can get the clarity. How many of a particular class? In our previous example, only 2 classes. So we have got 2 by 2 matrix. Here 10 classes, you will get 10 by 2, 10 by 10 matrix. Okay. But if you have 100 classes, right, looking at the confusion matrix and understanding is going to be very difficult. So that's where we actually try to do a graphical representation. Heat map of the confusion matrix will actually give you more clarity. So what is that heat map? Or if you look at this confusion matrix, this is how you should be understanding. These are all false negatives. Now, if you take this as 9, 8, 7, if you take this as a 7 class, these all the counts which are falling here are predicted as not 7. This is predicted as 0, this is predicted as 1, this is predicted as 2, false negatives. Okay, and this is true positives. Actually 7 and predicted 7, but false positives. These are all false positives. This is not this is not 6, but it is predicted as 6. This is not, so like that. Positive, it predicted as positive. It is predicted as 7, but they are not 7. Sorry, predicted as 7. It is 6, but predicted as 7. 5, predicted as 7. 4, predicted as 7. The false positives, these are all. So if you have to calculate precision now, what is the precision? True positives divided by true positives plus false negatives, right? So this score divided by all these scores is going to be, so divided by sum of all these scores is going to be the precision. Got it? This score divided by sum of all these scores is going to be precision of that particular class. 7 class. Understood? That is 7, right? 9, 8, 7, right? So if you have to calculate precision, 3,302 divided by sum of all these numbers. Do you agree? Sorry, that is recall, right?
Recall. Yeah, that is recall.
That is recall. Why? This is recall. Right?
Yeah.
Actual positives they are, and we are trying to predict how, we are trying to calculate how many are correctly predicted. This is recall. What is precision then for the 7 class?
Yeah, this
That
Column.
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 That column, right? This number divided by total of that
Sum.
column is going to be precision. Okay. For each class there will be precision recall, right? Do you agree?
Yes.
For each class there will be precision. Even in this binary also, for each class you can calculate precision and recall. For 0 class and 1 class you can calculate precision and recall. There is a method called as there is a function in scikit-learn matrix which actually gives you each class's precision and recall. So model needs one precision. If you look at the precision score, it has got one precision. If you look at recall score, one recall. But when we look at this, right, we are finding for each class there is going to be a precision, for each class there is going to be a recall. How did they calculated one precision and one recall? I'll explain that now. Okay, if you look at confusion matrix or the precision score, maybe I'll show you both. There is one more method which actually gives you I forgot the name of the function. Let us look at the metrics and then we'll see. So here, right, when you look at confusion matrix, there is nothing to explain. But in precision score, y true, y predict, you should be giving in the same order. If you flip it, right, the score will actually get distracted. So POS label I'll explain later. Okay, in SVM algorithm I used POS label. If you have multiple classes and you are trying to calculate precision recall, which class it should be considering as positive? No, so I'll talk about that later. Leave it. So average, right? Now when you look at this, for each class there is a precision. For the same class there is a recall, right? Sorry, this is recall, and that is 1, 2, 3, 4, right? So there is recall, there is precision. There is recall, there is precision. Like that, for each class there is a recall and precision. So to calculate one precision score, as it is giving here, it uses some averaging mechanism. Okay. So average is the technique. Default is binary. When you don't specify, it takes average as binary. But here I gave average is equal to weighted. If you don't give average, what happens? Let me run all above and show you. I think it will take some time.
Sir, meanwhile, can you just explain again that confusion matrix for that the numbers once again? Just above there is a matrix, right?
It's gone. It's gone. No, it will come.
Okay.
In a minute. Yeah, I will. So here, let us look at the mechanism first, and then I'll explain that and this in combination. Okay.
Sure.
Binary only reports results for class specified by POS label. So POS label, what is POS label? There are multiple classes in your data, right? There are 0 to 9 classes in your data. If you say POS class is equal to 6, right? It reports the results of the class. It reports the results of the class specific to POS label. So it is going to take. I said for each class there is going to be precision recall, right? So if you say POS label is equal to 6, it is going to output the 6 classes precision recall. Getting it? In a binary class classification, right? Default POS label is going to be 1. See this? POS label is equal to 1. That's where it is giving you the precision recall scores of one class. Confusing? Confusing?
No. Well,
Anybody else has got any questions? Yesterday some people did not attend, right? This is the core. This is the AI, right? You are missing classes. You shouldn't be missing classes. You spent money, right? You are spending time. Early morning you are waking up and, right? May not be early morning for some people, but so let me try to explain this a little bit and then I'll. This is going to be used in deep learning and all learnings. AI, whole AI, right? Metrics are very important. You have seen that, right? When you don't know how to label the data, the metrics will give you wrong impression, right? And metrics are very key in understanding how the model is working. Right? how can we calculate precision recall? You know that, right? So precision is going to be this direction, right? You take 2320 divided by 2320 plus 134. That is precision. Okay. Recall is going to be this direction, right? 2320 divided by 702 plus 2320. What is this precision is all about? Precision and recall are talking about which class?
Positive.
Positive class, right? If you have to calculate precision recall of negative class, how should we do? Let me take another color. You should take this into consideration, right? Correctly predicted, right? So now precision is going to be this direction, recall is going to be this direction. Okay. Now zero classes precision. So I'll say P1 R1, right? Class 1's precision and recall. For precision for 0 is going to be 30444 divided by 30444 plus 702. Now recall 0 is going to be 30444 divided by 30444 plus 134. Got it? So this is going to be 0 classes precision, and this is going to be 1 classes precision recall. Okay. So so for every either it is binary class or multi class, it doesn't matter. You will have precision recall scores for every class. Girigar, did you understand this?
Yes, sir.
Right, the same thing magnified there. When I try to explain that for every class there is going to be a precision and recall. Now, while calculating the precision score or recall score, there is an averaging mechanism and there is a POS label. Default POS label is 1. Default averaging is binary. So then what happens? Binary is saying what? Reports only the results for the class specified in the POS label. So one class's precision is going to be outputted. When you say precision score without specifying averaging, it is going to output this score, and when you calculate recall, it's going to output this score. Even in recall also, recall score method also, you will have average and binary. So there will be default POS label is going to be 0, sorry, 1, and then the averaging is going to be binary only. Got it? This is binary. Averaging mechanism binary. We are using averaging mechanism even on a binary class classification also. In a multi-class classification, you must specify averaging mechanism, rather it will throw error. I'm going to show that. For that I actually ran it. So if I take out this averaging mechanism and run it, right, see this, it's unable to understand. It took the binary as the averaging mechanism and the POS label is 1, right? There are 0, 1, 2 and so on n, but it has found many precisions and recalls. It doesn't know how to actually calculate, right? It is not, when you say binary, right, it is not calculating anything. It is taking the one class's precision and recall and outputting, right? When it found many classes there, then it is going to throw error saying that target is multi-class. Okay, so definitely you should use averaging mechanism. So when you have to use averaging mechanism, right, you need to understand what are all different averaging mechanisms are there and how they work. On an imbalanced data set, which averaging mechanism you should be taking. On a balanced data set, which you should be taking. You should understand this. I'm going to go there. So Girigar, what is your question on these numbers?
Yeah, I just wanted to explain once again what is the each number corresponds to once again.
Let me take a screenshot and explain. That way it's going to be better. So today morning I woke up late, so I'm in a hurry, right? So I may have settled down a little bit now, but generally it takes a little while. Okay, so here this is predicted. Right? This is actual. Yeah. So the classes, right? So let me take color 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Classes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So this is a confusion matrix. This is the confusion matrix, and now if you look at that, right, zeros predicted as 0 are this many, right? Do you agree? Actual zeros, there are many records, right? 3,300 odd records are there in 0 class, but 3,100 odd records are predicted correctly as 0. Got it, sir?
Yeah.
Okay. What about these? The 0 is predicted as 1, there are none of them. 0 predicted as 2, 5 are there. 0 predicted as 7, so 3, there are 7 are there. Like that. Okay. If you have to calculate precision, you will take, recall, you will take 3176 recall. Right, divided by 3176. 3176 plus 0 plus 5 plus 7 plus 5 plus 33 plus 21 plus 1 plus 49 plus 0. Okay. That is recall. If you have to calculate precision of 0, right, it's going to be in this direction, right? So total positive predictions, total 0 predictions, how many are correct, right? 3176 divided by 3176 plus 0 plus 14, right? This direction I'm moving, right? 14 plus 12 plus 7 plus 19 plus 17 plus 15 plus 12 plus 17, right? Like that, right? For this class, right, if you have to calculate precision and recall for this class, 4. Out of total force, 2,956 are predicted correctly. Let me take another color for this. Right? So 2,956 divided by, right? This is going to be recall of 4 is equal to, right, 7 plus 10 plus 25 plus 7, right? You see this, right? These numbers. 2956 plus 8 plus 21 plus 6 plus 91 plus 99. Okay. Precision is going to be 2956 divided by 5 plus 2 plus 32 plus 1 plus 20, 2956 plus 31 plus 16 plus 14 plus 4 plus 78. Right? Got it?
Yes, sir.
Now got it, right? So for every class there is a precision and recall. But when you actually look at the precision score methods output, right, let me run this. Precision scores output, it is giving one number. Which precision it is giving, which recall it is giving? That's the question I'm trying to answer now. Right? By showing you the averaging mechanism, that I'm actually trying to answer which score it is giving. If it is a binary class classification, it is giving you the one class's precision recall as output when you call precision score or recall score method. Okay. I think classification output or classification report. If you call classification report, right, it will give you. Let me try to show this on a binary class and multi. So this is like not that important, but some The research papers, right? They're actually gambling. So I wanted to show, right, some. Where is that? Precision score, recall score, do you see? Yeah, here. I wanted to show you what happens when you do, the classification report. See that? So zero class precisions recalls F1 scores, right? One class precision recall and F1 score. I don't know what is support. Support is the weightage, right? How many number of records are there belonging to 0? How many records are there for belonging to 1? Okay. So, and macro average, weighted average, you need to understand these. On a multi-class classification, you should definitely understand these averaging mechanisms, right? Accuracy. So classification report gives you. So what is the zero precision recall? This one. Zero precision, zero recall. Okay. One precision, one recall. By default, if you don't specify, if you on a binary class classification, the default values are that, so it's giving you one's output, right? This output it is giving by default. These are this output. See this 93 and 76, but 77 it's rounded off, right? It's two numbers it's showing, right? So 93 and 77. So it is giving you one class's output. Zero class output is hidden. So when you say classification report, it's going to give you. But we are least bothered about this. Why? We are least bothered about zero classes precision recall and F1 score. Why?
It's a majority class.
It's a majority class. You see, this is 98%, 99%. It's going to mislead. Researchers, what they are doing is they are taking the zero classes precision recall, one classes precision recall, and then they are taking macro average and showing that the model is working very good. You may also face this problem in the industry. Some people, right, some intelligent guys in the team may get you the macro average and show that the model is working good. Sometimes what happens is this is going to be 99%, but this is going to be 70% or 60% only. When you take average, right, it's going to be like 80% accuracy, right? 100 plus 60, 160 divided by 2 is going to be 80. Model looks like it's working good. Okay, so you need to be aware. Okay, you need to know where to focus. When metric is outputting something, where to focus, you need to be very careful of. I have seen one researcher from triple IT Hyderabad, right? The so profound university. That guy is actually doing this mistake, and he is publishing papers. Okay, so that's by brand people go, right? Now by brand people go, and it looks like a great thing when you don't know the details. Okay, so here let us look at other mechanisms. So micro calculates a micro global metrics globally by counting the total true positives, false negatives, and false positives. Understood this statement? Calculates micro by calculating total true positives, false negatives, and false positives. So it is going to take this whole matrix, right? This whole confusion matrix, and takes all true positives, all true negatives, right? With respect to all different classes, and then calculates average. That's going to be micro. Okay, got it? Got it? I hope you got it. Macro, right? Macro actually takes the each labels, um, uh, metric, no, the precision score, recall score, individually it calculates and takes the average of it, unweighted average. What is weighted average? See the support, right? Based on support, it will calculate weightage. Okay, so there are more number of records belonging to this particular class, so it should be given less weightage. You know, this class is having a less number of records, so it should be given more weightage, or it is going to be kind of normalized value, right? Not more or less, but it's a normalized value. This divided by total of this, and this divided by total of that. It's going to be like, you know, then you will multiply these scores with that weightage and then sum up. No? Multiply these scores with the weightage, multiply these scores with that weightage, and sum up and take the average. Okay, that way, you know, the score is going to be relative to the number of records in the data. Okay, that is called as weighted average mechanism in calculating precision and recall scores. Okay. For F1 score also the same metrics apply. When you calculate F1 score, right, what is the formula? 2 by 1 by precision plus 1 by recall, right? So while calculating precision recall, it's going to use the weighted mechanism and use those outputs as values for the F1 score. F1 score. Samples calculates metrics for each instance and finds their average. Only meaningful for multi-label classification. When we talk about multi-label, right, I'll talk about this. We'll talk about multi-label and multi-output classifications tomorrow. Okay? Then I'll talk about the sampling. You need to understand what is multi-label. Understood different ways of calculating average and why, what is the need of it while calculating precision and recall scores. Any questions? Okay, good. So when you are having, you know, more classes, right, the confusion matrix is very confusing to look at. So if you do heat map, you will be able to understand better. See that there are some you know, thick yellow block boxes here, right? What do they denote? Thick yellow boxes. What do they denote in a heat map? Thick yellow box, what is it denoting? So there is a thick yellow box.
Strong relation in linear regression, right?
Linear regression, strong relation, but in a
Strong
confusion matrix?
More in number, which is incorrectly predicted.
Very good, very good. There is a high number here. There is a high number here, right? When is it, then there is a high number on non-diagonal place. Is that an error?
Yes.
Incorrectly
Right?
predicted.
Yeah.
Yes,
3 is predicted as 5, right? So 3 is incorrectly predicted as 8. Right? 4 is incorrectly predicted as 8. So there are more values there. So when you look at heat map, right, you will understand. But if you look at this, right, the diagonal values, right, the diagonal colors are actually a little here and there, right, because of the count. There is less count here, so it is lighter. There is a more count here. There is more, you know, thicker because of the number of classes are more, or number of records were predicted correctly more. Okay, so but if you normalize these values, you will get a little more clear picture. See that here. So the diagonal values are a little more, little more, in uniform color, right? To bring them to uniform color, what you need to do? Bring those numbers to uniformity, okay, to a similar scale. When you have to bring some numbers to similar scale, what you do? What do you do to bring some numbers to similar scale? Yes, divided by maximum. Divided by maximum, right? So I have taken, see this here, I took sum of all the rows here. Right? This is confusion matrix. So here the confusion matrix, right? This is the whole confusion matrix. And then let's say numpy array, right? And then what I did some method on axis 1 and keep dims true. Do you remember? This is confusion. This is I explained in the numpy arrays. So it is going to keep the dimensions as two-dimensional matrix a two-dimensional matrix. There is a reason for keeping it. Even if you don't keep it, that works. But I intentionally kept it. Okay. And then axis 1, I am saying, when I say axis 1, right, it is going to sum up all columns and make one column. See this? It actually summed up all the columns there. No, it summed up all these numbers, all these numbers, all these numbers. Right? Because I said axis is equal to 1. By default, axis 0. It would have summed up in this direction. No, I don't want it. I want actual values, right? Actual values from the data set. And then I divided my matrix. See, the confusion matrix divided by row sum. This is the row sum, right? When I do this, what happens? Broadcasting happens. What is broadcasting? Do you remember? What is broadcasting? If you divide a two-dimensional matrix with a one-dimensional matrix, so with a column matrix, one-dimensional matrix, what happens?
So each element in the row gets divided by the corresponding
Yes.
element.
See this here? I'll show you. I think division. Matrix. Subtraction. Addition. Where is division? So these are all very simple concepts but used extensively in AI. Okay, if you have to focus a little bit here, right? See this? When I took a two-dimensional matrix and dividing with a column matrix, what is it doing? It is dividing 8 by 2, sorry, 8 by 2, 3 by 2, 5 by 3, 1 by 3, and we got it. Same thing we did there. It's a big matrix. This is a column matrix. Okay, the same operation we did here. Okay, this is confusion matrix divided by row sum is going to be same operation. So when you did that, right, what happens? All the numbers will come into similar scale, right? So between 0 and 1, the numbers will come between 0 and 1. That way, the colors are going to be a little balanced, and now you see the patterns very clearly. See, where is all wrong predictions are happening here, 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 right here. So the colors are going to be more evident. Wrong prediction colors are going to be more evident. Okay. So by looking at confusion matrix, you can understand better. That too, when you normalize the data and then normalize the confusion matrix and then do the plot, it will be even better in understanding which class is misclassified as other class. Okay, if you see some class is misclassified as others, you can take only those two classes precision recall scores and play with them and make the model work best on those two classes. Got it? Yesterday, Seshram asked if if one class is predicted out of all the 9 classes, 1 or 2 classes are being misclassified more, what we should do? By after looking at this confusion matrix, you take control over those precision and recalls of only those classes. It is going to be a bit complex, and model need to, when you are deploying it in production, right? Model, the record will be passed to model and made prediction. Again, the record will be passed to the your own whatever stuff, right? And then you need to make prediction there also. It becomes a bit complex. I don't know whether you got it or not. I'm actually moving on. I'll start. We'll discuss this at the end of the class. Okay. So weighted average I have taken because there is the data set is imbalanced, so it's going to give more weightage to the my majority class and my less weightage to the minority class and things like that. Okay. And I think I took the test set and then applied the transformation scaling and then predicted and calculated the F1 score. I have got 90% accuracy. So yesterday we have seen how to do one versus all classifier and one versus one classifier. If somebody is missing, right? Please watch that video. It's a simple thing. Okay. And that's about the multi-class classification. There is one more important algorithm called as softmax regression classifier. So far you are clear, right? Any questions till here?
Sir, can you go a little up, sir? See here. Oh, no. Oh, yeah, little up. Not the one was previous one. Here, if you see that, come down. Come down, sir. Not the matrix. Say average is weighted. It's a F1 score. The F1 score for what? It's for 0 or like 1 or 2 or 3?
That's what it is, right? So, yeah, that's a good question. Basically, you are actually thinking. You understood that every class will have its own precision and recall, right?
Yes.
Right? When you are using precision recall with weighted average, what is it happening? It is taking individual precisions and recalls.
Recall, okay.
Based on the count of each class, it is calculating some score, some weightage, and multiplying that weightage with the precision recall and taking average.
Okay.
Right? So to calculate F1 score, what you need? Precision and recall, right? So it is
Yes.
going to calculate weighted precision, weighted recall, and then calculate F1 score. That's it. So out of all those numbers, it is calculating one number, precision. Out of all those numbers, it is calculating one recall. Using that one precision, one recall, it is calculating F1 score. Whichever average mechanism you specify, that mechanism is going to be followed.
Okay.
Right? Look at the API, look at the nodes, and now think a little bit and come back. So I would say I'll stop it here because it's too much today. And softmax regression classifier, we are going to use it in deep learning again. So we need to understand this also a bit better. So we'll start with this and we'll jump into the multi-label and multi-output tomorrow. Is that okay? Is it okay?
Yes, sir.
Yeah. So I'll stop recording. Any questions you can ask.